Hi everyone, myself B. Praveena. I'm the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about my topic is for finding eigenvalues and eigenvector problems on 2 by 2 matrix. For 2 by 2 matrix. Okay, for that first I'll discuss with the first question. Find the eigenvalues and the eigenvectors of 8 minus 4, 2 and 2. Okay, already we discussed in the last class. Okay, how we are finding the eigenvalues from the characteristic equation. From the characteristic equation. If the characteristic equation, how we are getting that equation? A minus lambda I. For that, if you are finding that A minus lambda I is equal to 0, for that we get one characteristic, that is the characteristic equation. After simplifying that, we get two values. The two are called as the eigenvalues. Okay, here how we are discussing about that by using the how we are finding that eigenvalue problem from the characteristic equation. What is the form of the characteristic equation? Det A minus lambda I is equal to 0. For that, first we have to write it as characteristic matrix form. What is that characteristic matrix form? That is A minus lambda I form. A minus lambda I. For that, okay, what is A there? This is 2 by 2 matrix, that is 8 minus 4, 2 and 2 minus lambda into 1, 0, 0, 1. Okay, this is the characteristic matrix. From that, write it as the matrix form, that is 8 minus lambda minus 4, 2 minus lambda and 2 minus 0, 2 and there 2 minus lambda. This is the characteristic matrix. For that, we have to find det A and equating with 0, that is called as the characteristic equation. That is called as the characteristic equation. Okay. Okay. After getting the characteristic matrix and I'm finding that determinant value. For that, it is simple matrix, that is 2 by 2. For that, take the cross multiplication of that. For that, finding determinant of the value, that is 8 minus lambda into 2 minus lambda minus of minus 4 to 2 is equal to 0. That is, okay, here 8 into 2, 16 minus 8 lambda, next minus 2 lambda plus lambda square plus 8 is equal to 0. From that, lambda square minus 10 lambda plus 16 plus 8, 24 is equal to 0. Now we have to find that roots for the given equation. For that, how we are finding that values? That is, write it as minus 6 lambda minus 4 lambda plus 24 is equal to 0. From that, we get directly lambda minus 6 and lambda minus 4 is equal to 0. Therefore, what are the eigenvalues for that? Lambda is equal to 6, 4 are the eigenvalues. This is the lengthy procedure. After getting that characteristic equation from that calculator, from the scientific calculators, we have to take that equation form. From that, we have to substitute the coefficients. Directly we get lambda values, that is 6, 4. That is the easiest method for finding the eigenvalues after getting the characteristic equation. Okay, or else apply for this method. From that, directly we get lambda values are 6, 4. For that, here for the 2 by 2 matrix, here we get two eigenvalues. Now we have to find that corresponding eigenvectors. Okay. What about the first eigenvalue? That is lambda is equal to 4. Okay, that is lambda is equal to 4. For finding eigenvector, this is case 1. Okay, what about the formula for that? That is A minus lambda into I, x is equal to 0. That is the formula for finding eigenvector. But here, what is lambda value? That is minus there. a minus lambda value 4 into I. X means number of unknowns there. X1, X2 is equal to 0. From that already we discussed in the a minus lambda I in the previous one. There in that a minus lambda I have to substitute lambda value as 4. That is, what is a minus lambda I? 8 minus lambda minus 4, 2 minus lambda into x1 x2 is equal to 0. Here we have to write it as again that characteristic matrix, that is 8 minus lambda minus 4, 2 minus lambda, x1 x2 is equal to 0. Okay, for that mm, here substitute lambda value as 4, that is 8 minus 4 minus 4, 2 minus 4 into x1 x2. Here x1 x2 means in the given matrix is 2 by 2. For that we have to find two unknown values. For that we have to take x1 x2 column matrix. Okay, here 8 minus 4 means 4 and minus 4 and 2 minus 2 into x1 x2 is equal to 0. From that this is 2 by 2 matrix. For that easily we can find. Okay, write it as that equations form. Okay, from that solve the two equations directly we get x1 and x2 values. Okay, first write it as equations form. Okay, first row with the first column, that is 4x1 minus 4x2 is equal to 0. That is the first equation. Let us consider that as the first equation. And similarly from the second column with the second row, that is 2x1 minus 2x2 is equal to 0. This is that. Okay, right. Let us take that as the second equation. From 1 and 2 we have directly x1 is equal to x2. X1 is equal to x2. How you got? Once observe the second equation here, I'll take 2 common from the second equation. This is second equation. From that I'll take 2 common. X1 minus x2 is equal to 0. From that x1 is equal to x2. That means we get directly x1 is equal to x2, but we are not getting x1 value separately and x2 value separately. But here x1, x2 are unknowns, so that we can find out the each and every value individually. But here from the equation solving after we get x1 is equal to x2. For this case we have to assume one value as arbitrary constant. Okay, for that I am assuming let x1 is equal to alpha. Let x1 is equal to alpha, then substitute there. Then if x1 is equal to alpha means, if x1 is alpha means from that substitute in the above one, then x2 is equal to alpha. Therefore, what about x1 and x2 values? Alpha and alpha. Write it as eigenvector form x1 x2 and x1 value alpha and x2 is equal to alpha. From that I am taking alpha common, that is 1 1. Therefore, what about the eigenvector for this? If lambda is equal to 4, for that corresponding eigenvector is 1 comma 1. Therefore, 1 and 1 column vector, one column matrix is a eigenvector of a matrix A, corresponding eigenvalue of lambda is equal to 4. This is the procedure for the 2 by 2 matrix for finding eigenvalues and eigenvectors. And once observed, there we get two eigenvalues are distinct. For that case, we have to find the two corresponding eigenvectors. Okay. Case 1 over. Now I am finding that case 2, if lambda is equal to 6, for that case we have to find that corresponding eigenvector. Here lambda is equal to 6, for that same concept here a minus lambda I into x is equal to 0. For that what about is lambda value there 6 into I into x is equal to 0. From that this is 8 minus lambda. And what about the A minus lambda I matrix? 8 minus lambda minus 4, 2 and 2 minus lambda. 2 minus lambda into x1, x2 is equal to 0, 0. Here lambda value, how much that lambda value? 6. That is substitute there 2 minus 6 into x1, x2. x1, x2 is equal to 0 comma 0. Here 8 minus 6 means 2 and minus 4, 2, 2 minus 6, minus 4. Here x1, x2. The two rows are similar. The 2 minus 4 and 2 minus 4. Write it as equations form, that is 2x1 minus 4x2 is equal to 0 and 2x1 minus 4x2 is equal to 0. From that's all the two equations, again we get x1 is equal to there 2x2. x1 is equal to 2x2. Once observe here, what about x1 value? x1 value in terms of x2. From that x2 is also in terms of x1 but not getting the values individually. For that case, again we have to assume x1 as arbitrary constant. From that we get directly x2 value. For that, let us take x1 is equal to alpha, okay, or else x2 is equal to alpha, or else x2 is equal to alpha. From that we can directly substitute in the above one, then we get x1 is equal to 2 alpha. x1 is equal to 2 alpha. Therefore, what about the eigenvector there? x1 is 2 alpha and the second one is alpha. From that I am taking the constant outside, that is alpha. Then the remaining part column has 2, 1. That is the corresponding eigenvector if lambda is equal to 6. Okay, this is the concept for finding eigenvalue and that corresponding eigenvector. So that write it as the last line here. Here last line, if lambda is equal to, what about the first eigenvector? 4. Lambda is equal to 4. For that eigenvector, okay, x1 x2 is equal to, what about that? 1 and 1, is it right? Okay, 1 and 1. And if lambda is equal to 0, for that case eigenvector x1 x2 is equal to 2, 1. This is the conclusion of the answer. Okay, this is the procedure for finding eigenvalues and the corresponding eigenvectors. Okay, next similar question and discuss. Okay, find the eigenvalues and eigenvectors of the matrix. For that, what about the matrix A is equal to 5, 4, 1, 2. Okay, then A is equal to 5, 4, 1, 2. Given matrix 5, 4, 1, 2. From that, what about the characteristic equation for finding eigenvalues? Det A minus lambda I is equal to 0. From that, what is A? 5, 4, 1, 2 minus lambda into, this is 2 by 2 matrix, so that I am taking 2 by 2 identity matrix, and for that I am finding the determinant value, that is 5 minus lambda 4 and 1 and the next one 2. Okay, there 1, 2 minus lambda is equal to 0. After that, okay, find the determinant. 5 minus lambda into 2 minus lambda minus 4 is equal to 0. For that 5 into 5, 10 minus 5 lambda minus 2 lambda plus lambda square minus 4 is equal to 0. That is lambda square minus 7 lambda plus 6 is equal to 0. For that, what about the roots for that? That is lambda square minus 1 lambda minus 6 lambda plus 6 is equal to 0. From that, I'll take lambda common, that is lambda minus 1. Here I'll take minus 6 common. Lambda minus 1 is equal to 0. There, lambda minus 1 into lambda minus 6 is equal to 0. Therefore, lambda is equal to 1 and 6 are the eigenvalues. Eigenvalues. So that here for that given 2 by 2 matrix we get that eigenvalues 1 and 6. These two are similar or distinct? These two are distinct. For that each and every value, now we can find out that corresponding eigenvector. Okay, for that, okay, if lambda is equal to case 1. That corresponding eigenvector. If lambda is equal to 1, that corresponding eigenvector. For that, what is the formula? That is, for that, what is the formula? A minus lambda I into x is equal to 0. For that, what is A minus lambda by I? 5 minus lambda 4, 5 minus lambda 4, 1, 2 minus lambda into x1, x2 is equal to 0. Here, what about lambda value? 1. 5 minus 1, 4, 1, 2 minus 1 into x1, x2 is equal to 0. That is 4, 4, 1, 1 into x1, x2 is equal to 0. For the 2 by 2 matrix here, how many unknowns are there? 2. Okay, now write it as the equation form. That is 4x1 plus 4x2 is equal to 0. Second one, x1 plus x2 is equal to 0. Solve 1 and 2. Solve 1 and 2. Okay, from that second equation directly, okay, no need to solve that 2 from second equation or first equation directly. From second equation, x1 is equal to minus x2, or else from the first equation also we get same, x1 is equal to minus x2. That means here we are not getting directly x1 and x2 values. For that case, we have to assume x1 as k or alpha. x1 as k or alpha. Okay, substitute in the above one. Substitute x1 is equal to k in the above condition. From that we get x1 is equal to minus x2. x2 is equal to minus k. Okay, if x1 is equal to x2, from that I'm assuming x1 as k. From that, what about x2? x2 is also minus k. Therefore, if lambda is equal to 1, for that case, what about the corresponding eigenvector? x1, x2 is equal to k minus k. I'm taking from that k outside, that is 1 minus 1. Therefore, if lambda is equal to 1, that corresponding eigenvector 1 minus 1. Okay, this is the first eigenvector if lambda is equal to 1. And the second eigenvalue, lambda is equal to 6. Okay, case 2. If lambda is equal to 6, that corresponding eigenvector For that, what about the formula? A minus lambda I into x is equal to 0. What is A minus lambda I? 5 minus lambda 4, 1, 2 minus lambda into x1, x2 is equal to 0, 0. Here, what about lambda value? 6. That is 5 minus 6, 4, 1, 2 minus 6 to x1, x2 is equal to 0, 0. That means here 5 minus 6 is minus 1, 4, 1 minus 4 into x1, x2 is equal to 0, 0, 0, 0. From that, write it as again in equations form, that is minus x1 plus 4x2 is equal to 0. And the second equation, 1x1 minus 4x2 is equal to 0. Let us take this as the first equation and this as the second equation. From the second equation, x1 is equal to 4x2. x1 is equal to 4x2. That means here again we get x1 is in terms of x2 or x2 is in terms of x1. There is no direct individual values for the x1 and x2. For that case, let us assume x2 is equal to k. x2 is equal to k. Substitute in the above one. From that, x1 is equal to what? 4 into k. Okay, therefore, if you are assuming x2 as k, from that, what about x1? x1 is equal to 4k. Therefore, here, what about the matrix? x1, x2 matrix, that is, x1 is 4k and x2 as k. From that I am taking k common, that is 4, 1. Therefore k is 4 comma 4 and 1. Therefore if lambda is equal to 6, if lambda is equal to 6, that corresponding eigenvector, that corresponding eigenvector is 4 and 1. Okay, this is the eigenvector for the corresponding eigenvalue of lambda is equal to 6. Okay, this is the procedure for finding eigenvectors. Okay, from that write it as the last conclusion. Here I'll write it as the last conclusion. That is therefore if lambda is equal to 1, that corresponding eigenvector, first one, 1 minus x1, x2 is equal to 1 minus 1. If lambda is equal to 6, that corresponding eigenvector, x1, x2 is equal to 4, 1. Okay, this is the answer for the 2 by 2 matrix. Okay, the corresponding eigenvalues and eigenvectors. Okay, this is the concept for finding eigenvalues and eigenvectors for the 2 by 2. Okay, what's the concept for that? First we have to find the eigenvalues. If the eigenvalues are distinct means for that case, we have to find two the corresponding eigenvectors. If the if the two eigenvalues are similar, for that case, in that one case only we get two eigenvectors. But here in the two questions, the two eigenvalues are distinct, so that we get directly in the two cases the two corresponding eigenvectors. This is the concept for finding eigenvalues and eigenvectors for the 2 by 2 matrix. Okay, next class we will discuss with the same concept with the 3 by 3 matrix. Thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.